Hi, this video is to demonstrate the naming of ionic compounds. So, ionic compounds, remember, must start with a metal. For example, sodium or nickel, these are all metals. Metals, remember, are found to the left of the stair-step. Here is the stair-step dividing line. Metals are all found to the left of it, non-metals to the right. So first step is, if it starts with a metal, it is an ionic compound. Next, we need to locate it on the periodic table and come up with its name. Now, first one we have here is Na. We find Na here in the very first column, sodium. Now, if it is in columns, if the metal is in columns 1, 2, or 13, that means that it has only one possible charge for sure. And therefore, all you need to do is write down its name. So sodium, Na, we simply write down sodium, and then we'll go on to the ion, to the anion, the negative part. However, with Ni, we find Ni is right here, number 10, nickel, number 28, yet it's in column 10. Therefore, that does not have, for sure, only one possible charge. All right, in that case, we then have to look for it on the back of the periodic table on our list of common ions. The list of common ions is divided into positive cations and negative anions. The positive cations, if you notice, some elements are listed only once, like cadmium. Other elements, like cobalt, are listed more than once. If they are listed more than once, you will need to include a Roman numeral that indicates its charge, and the Roman numeral will be in parentheses after the name of the cation. In this case, we're looking at nickel, and we're looking for it. It is down here. Nickel, if you notice, is written more than once. So when we're writing its name, we write down the name of the element, and nickel, and since it is listed more than once on the back of the periodic table, we include parentheses. Now eventually we're going to put some Roman numerals in that parentheses. Until then, we leave it blank. Moving down, Mg. Mg is found in column 2. It's right here, it's magnesium. Since it's in column 2, for sure it only has one possible charge. Therefore, we simply write its name. And then finally, Cd, we look for Cd, and we find that that is right here, number 48, cadmium. And it's in column 12. So since that's not in columns 1, 2, or 13, we turn it over and look for it on the back of the periodic table. And it's right here. Notice how it's listed only once. Therefore, we do not need a Roman numeral. We simply write cadmium. Now, once we have named the cation, we then move on to name the anion. Now, the anions come in one of two varieties: monoatomic anions or polyatomic. Monoatomic means that they have only one atom, or more specifically, one element. For example, both of these are monoatomic anions. This has only chlorine, this has only fluorine. Down here, we have MgSO4. SO4 is a polyatomic ion. It has more than one element, both sulfur and oxygen. Same thing here, the PO4 has both phosphorus as well as oxygen. Therefore, we call these polyatomic, poly for many, atomic for atom. Monoatomic anions are named simply by taking the name of the element and taking the root of that name and adding IDE. For example, Cl is chlorine. We take the root of that, drop off the ene, and add IDE for chloride. Same thing here. With the F, we have fluorine, but instead of fluorine, we drop off the ene and simply write fluoride. All right, that's how you do monoatomic anions. Polyatomic anions, you simply use the back of your periodic table and you look it up by the formula. So we look for SO4 and we see it is right here. SO4, which has a -2 charge, is called sulfate. So I simply write down sulfate, and that's the name of that ion. Here, PO4, I look down here, I look for PO4, and it's right here. PO4 is called phosphate. So I write down phosphate. Now, for those compounds, for those ionic compounds that have where the cation has only one possible charge, we're done. The name of NaCl is sodium chloride. Name the cation, name the anion. Magnesium sulfate is the name of MgSO4. CD3PO42 is cadmium phosphate. A quick word about the parentheses in the formula here. You only use parentheses when you are writing more than one of a particular polyatomic ion. This right here indicates that we have 2 phosphates, and that will come into factor later on. Now, back to here. We now need to figure out what the charge is inside the parentheses. Well, the way that works is you have to remember 2 things. One, that unlike positive cations, negative anions only ever have one possible charge. And 2, that all ionic compounds must be electroneutral. Electroneutral, which means that the charge has to equal 0. So all the positives, when you add them up, must balance out and equal to the negatives. Now, looking at here, fluoride. Right? Basically what we're going to do is we're going to use the negative charge of fluoride and the fact that the entire charge must equal 0 to figure out what the positive charge of the nickel must be. Now, fluoride is found in column 17. As we learned before, since column 17 elements have 7 valence electrons, they want 1 more. Therefore, when it becomes an ion, it always takes on a -1 charge for that extra electron that it takes on in the reaction. So, we know that each fluoride is -1. Now we look to the formula and see that there is a subscript of 2. That tells us there are 2 fluorides. Altogether gives us a negative charge of -2. Because it has to be electroneutral, we know that the total positive charge is going to have to be +2 so that it balances out, so that it cancels out. Now this nickel, we look at the formula, there's only 1 of them. And therefore, it has, since there's only 1, we say, well, what charge does that nickel have to be so that it gives us a total positive charge of +2? And the answer, of course, is +2. The Roman numeral is what the charge of the cation is. So since that's +2, that means that it's nickel 2 fluoride. Let's take a look at one more. Let's say we have Fe2 C2O4 3. Now, the first element, Fe, we look on our periodic table, it is iron. It is not in columns 1, 2, or 13. So we look for it on the back of our periodic table, and we see that iron is right here, and it is listed more than once. It can either be iron 2 or iron 3. So I'm going to write iron, parentheses, since we don't know what its charge is. Note how the charge is almost never the same number as the subscript. So don't get confused. The Roman numeral does not necessarily match the subscript. Instead, it's going to be the charge of iron. Next, we look up the anion. Since it is made up of two elements, carbon and oxygen, that means it's a polyatomic ion. We look for it back here under C2O4, and we see that its name is oxalate. So we call it oxalate. Now, once we have that, we now need to figure out the charge. Again, we use the back of the periodic table, oxalate, and see what charge it has. You notice it has a -2 charge there, which means it has a -2 charge there. Then we use the subscript to tell us that there are 3 oxalates. Remember, parentheses with the subscript on the outside. That subscript tells us how many of that particular polyatomic ion we have. We have 3 oxalates, each one's -2, to give us a total charge of -6. That means the total positive charge is +6. How many irons are there? There are 2 irons, which means, we have to figure out what charge is each iron that when you add them up, it equals 6. What times 2 equals 6? The answer, of course, is +3. That +3 tells us the Roman numeral in the parentheses is therefore going to be a 3. Let's look at, just for another example, one last example, and look at Pb parentheses CO3 2. All right? Actually, yes, we'll go for that. Now, Pb, we look for it on the back of the periodic table. We find it right down here. Notice how it's in column 14, not 1, 2, or 13. So we look for it. It's called lead. And we look for it on the back of the periodic table. And we see that lead is listed more than once. So we must include a Roman numeral. Next, we look for CO3. Capital C, capital O tells us it's 2 elements. It's polyatomic. So looking on the back of our periodic table for CO3, we find it here, and it's carbonate. Also note that it is -2. So we say that it is carbonate. Now, since we know that each one is -2, and we see that there are 2 of them, the total negative charge is -4, which means the total positive charge has to be +4. And we look at the formula, there's only 1 lead. If there's no if there's no subscript, it means you only have 1 of it. So the question is, what times 1 equals 4? And the answer, of course, is +4. That tells us that the Roman numeral is going to be 4. So this formula is called lead 4 carbonate. So, one more thing on naming hydrates. Basically, a hydrate is an ionic compound that has water molecules placed or soaked into the crevices, into the crystal lattice. For naming purposes, it's very simple. You name it just like you would any other ionic compound for the first part. We have Ca, which is calcium. It's in column 2, so there is only one possible charge. So we simply write calcium. For the second part, it is a polyatomic ion. So we look on the back of the periodic table, and we see that it is called carbonate. All right, so we write carbonate. And then for the .7 waters, it is a hydrate. So what you do is you simply use a Greek prefix indicating how many waters there are. And the list of that can be found on page 4 of your learning packet. It's right here. So for 7, in this case, the answer is hepta. So the prefix is hepta. So I simply write hepta, and then I finish it. For water, I write hydrate. So this is calcium carbonate heptahydrate. That is all.